Romain di Stasi from the Laboratoire of Compared Éthologie and Developmental Cognition from the University of Nanterre, France.
Okay, can you hear me? Yeah? Okay. Hello everyone. I will talk to you about our study, which assesses the influence of humor on learning in infants across a multidimensional approach. This project is carried by Lauriane Radfischer and Rana Esseli. First of all, how can we define humor? It can be defined as a feeling or expressing something incongruous, surprising and funny. The last are accompanied by a positive emotional response such as joy and specific behavior such as laughing or smiling, and are present in whole culture and it's to some extent universal. Humor has a positive influence on learning in adult and school-age children. In infants, few studies have been conducted despite the fact that they seem to be able to perceive humor around 5 months. One of the few studies to have investigated the influence of humor on learning in infants was conducted by our team. In this study, 18-month-old infant had to use a rake to retrieve an out-of-reach toy with a rake after a demonstration of its use by an experimenter. The experiment was performed as follows. As you can see, we start by doing a pretest to see if the infant retrieves the out-of-reach toy before the demonstration of its use by the experimenter. And you can see in general, only 10% of infants are able to do this at this age. You can see the fact that the infant does not connect the toy on the rake, and it's difficult for him. And after this test, the experimenter showed how to use the rake to retrieve the out-of-reach toy. The demonstration is repeated 8 times and could be done in humorous or in neutral way. Here in the video, it's a humorous demonstration, and during this demonstration, when the experimenter retrieves the toy, she throws it over her shoulder and say amusing vocalization like, it's up, like this, okay? In the neutral demonstration, instead of throwing it away, she put it just in the box. It's a control demonstration. You can see the fact that infant laugh during this demonstration is approximately the case for 30 to 40% of infants when they are exposed to this kind of demonstration. Okay, then we test infants again to see if or she has learned to use the rake by imitation. And as you can see, the infants here successfully imitate the use of the rake, and this is a perfect gesture of imitation in this case. Finally, the results were infants who laughed performed better than other infants exposed to humorous demonstration and those exposed to neutral one. Thus, humor seemed to have an influence on learning in infants as young as 18 months old. But this study does not answer a number of questions. Is it a general effect of humor or more specific to laughter? Is it linked to inter-individual differences? Infants who laugh during the demonstration may have socio-cognitive ability or temperaments that make them more inclined to learn than the others. Positive emotion induce an activity of the sympathetic nervous system, which are correlated with arousal. And some authors suggest that there is an effect of arousal on performance in learning in adults. Is it possible to observe this relation between these two components in our context? And finally, can it be generalized to other ages than 18 months old? In our study, we have 3 main questions. Either developmental effects of humor on learning during the second year of life. When do infants start to laugh at our humorous demonstration? Is the emotional reaction observed in humorous condition related to inter-individual differences? And emotional intensity is positively correlated with learning in adults. Can we observe this in infants? To answer this question, we perform an experiment with a multidimensional approach. We use the same procedures as in the previous study at different ages from 14 to 22 months old. In addition to behavioral analysis, we perform physiological analysis by using a wristband to extract physiological data in non-invasive way. It's the case for both cardiovascular data and it's electrodermal data. And the idea to extract this type of data, it's just to assess the intensity of emotion, also called arousal. And by using this type of data, it will be possible to see if intensity of emotion is positively correlated with the learning performance. In addition, testing infants of such varied ages allows us to test the age at which they are sensitive to this type of humor. In other words, to test at what age will they laugh at this kind of humor. And we will combine this analysis with automatic facial expression analysis to identify the emotion that the infant feels during the demonstration. And finally, we perform temperament analysis by using the questionnaire called OCBQ to determine whether the observed results are not related to inter-individual differences. Here we have the result concerning the tool use score after demonstration. The first graph presented here shows the performance of tool use after demonstration as function of age in day and as function of the type of demonstration. In blue, the slope represents the neutral demonstration. The red one represents the humorous demonstration. The tool use score in y-axis here represents the tool use, the best tool use score after demonstration concerning the tool use ability. 1 and 2 were failure, 3 is a success with trial and error, and 4 is a full success. The second graph here represents the influence of the type of demonstration on learning, and is approximately the same. And we can see there is an overall increase in imitation of tool use after demonstration with age. There is no interaction between age and condition, and infants seem to learn better when they are exposed to humorous demonstration comparatively to neutral one. And this result can be explained in two principal ways. Either the humor had an effect on learning, or the humorous demonstration had a more salient aspect that motivated the infants to imitate. Another interesting effect is that there will be a general effect of infants' emotional reaction during the demonstration. In fact, for both conditions, infants who laughed or smiled seem to have a better tool use performance than the others, and this is completely independently of the type of demonstration. This information makes sense to us since the neutral condition is not completely neutral. Otherwise, it would make the situation awkward for the baby. And for this reason, some infants smiled or laughed during the neutral demonstration. In fact, of the 41 infants which are exposed to neutral demonstration, 5 laughed and 11 smiled. Okay. Another interesting fact is the fact that infants laughed at the humorous demonstration from 17 months. Infants during the demonstration get towards the experimenter more and longer when they are exposed to humorous demonstration than the neutral one. And the frequency and duration of gaze towards the experimenter can indicate infants exposed to humorous demonstration are more surprised than the others. Since surprised will be an important component of humor and would have a positive effect on learning, this result may explain why we have an effect of the type of demonstration in addition of the emotional response during the demonstration. Another interesting finding that we did not anticipate is concerning the temperament analysis. In fact, infants who laughed also had the higher negative affect score than the others, and that is to say, laughing infants during the demonstration have the most difficulty to regulate their own negative emotions than the others. This is especially the case when the infants have siblings, and laughing infants are they more anxious? This is in line with some old hypotheses about the link between humor and attachment and affiliation. In fact, according to some authors, infants who are less securely attached than others have a lower threshold for laughter, and laughter is a kind of signal. being noisy and highly contagious. It's a kind of signal, and it will serve to reinforce the bond between the parents and infants, and this result supports this hypothesis to some extent. Concerning the physiological analysis, we wanted to see if there was a link between arousal, also called the intensity of emotion, and learning. And you can see in the first graph on the left, the lower the heart rate on the infant during the demonstration, the more successful they were in using the tool after demonstration. This is not in line with we expected. We thought that higher intensity of emotion will lead to better learning performance in infants. Nevertheless, this result may also suggest that successful infants are also the least stressed. If we consider the heart rate as function of the emotional response, we can see on the graph on the right the fact that individuals have a significant increase in heart rate during the demonstration when they are neutral and smile, but it's not the case when they laugh. It's possible that laughter has a different effect than other emotional reactions, since the literature suggests that it influences the production of endorphin, and that the latter has a heart rate lowering effect. So it will be interesting to look at the signal curve with more precision to see if we can observe something like this curve. Here there is a stimulus and there is an increase in the heart rate, and the laughter induces a production of endorphins and decrease the heart rate signal. And furthermore, by doing this kind of wave analysis, we will be able to use for example, the McCarthy methodology is illustrated here, which considers the cardiac variability to assess the valence of the subjects. According to this methodology, an irregular pattern of heart rate variability is associated with negative emotion, and a regular pattern is associated with positive emotion. And by using this methodology, it is possible to perform more refined emotional analysis in order to observe possible positive or negative emotion reaction during the demonstration. We are currently working on such an algorithm to analyze our data. Furthermore, we combine it with the facial expression analysis. To conclude, we do not notice a specific effect of laughter as in the study of Esseli and colleagues. However, we observe a general effect of emotion, since the infant who laughed or smiled performed better than the others, and this regardless of the type of demonstration. We also observe that infants exposed to humorous demonstration perform better than the other. It is possible that the humorous demonstration is simply more salient than the neutral one. However, the fact that infants gaze more towards the experimenter during the humorous demonstration suggests a potential surprise effect. Nevertheless, this will need to be confirmed with further analysis, obviously. The link between laughter and negative affects will be associated with the hypothesis that laughter has a function in the parents-infants relationships to strengthen their bonds. And it could also be that particularly stressed infants use laughter more than the other. It will be just consistent with the hypothesis that laughter has a stress-reducing function. And finally, the most successful infants were also those who had the lowest heart rate during the demonstration, and these were also the ones who smiled and laughed. However, the fact that smiling leads to an increase over baseline suggests that there is an effect of emotional response on the autonomic nervous system. Laughter would induce neither an increase nor a decrease. It is possible that the demonstration had an effect of arousal, but that laughter led to a decrease in heart rate. We can interpret this as an effect of stress reduction, but an analysis of the shape of the heart rate will be necessary. It is possible that there is an increase and then a decrease that will not be seen if we consider only the mean. Okay, we are currently working for the future direction on the algorithm to assess the Earth wave based on the same kind of methodology using the ECG. In this way, it will be possible to explain what physiological mechanism explain why infants who smile and laugh perform better than the others. Since surprise is at the heart of all humorous situation, we are also working on the baby face reader software from nodules to identify this emotion. We have set it up automatically identify when infants make a facial expression of surprise based on the facts on baby facts methodology of Izzard, Ekman, and Oster. And by performing this kind of complementary analysis and by performing other experiments, we hope to be able to evaluate the influence of surprise in learning in our humorous context. Before finishing my presentation, I would like to thank my two supervisors, Lorraine Radfischer and Rana Esseli, as well as the trainee who work in this project, our research engineer, Fabien Serrotti, and all our financial supports. Thank you for your attention.
Okay, thank you, Romain, for the very interesting talk. And do we have time for questions? There's a question in the front.
There is some really nice classic work by Richards looking at heart rate variability, and things like sustained attention that can lead to better encoding. So that work might be useful in contextualizing this once you have the ability to look at the infant's fluctuating heart rate and whether or not it's going down during the demonstration and then up at the moment of humor, right? This is going to sort of like crescendo and increase as the infant says, is this person going to keep doing this ridiculous thing? So they're waiting, they're anticipating, they're attending, their heart rate is slowing, they're encoding better, and then up and then back down, right? It gets into sort of a rhythm. So I think your idea to break this out and not just look at the means is going to be very fruitful, especially if you look at this classic work.
Okay. Sorry, I don't understand exactly what is your question concerning this. Can you? Yeah, there is no question. Okay, it was okay. Thank you.
Are there any other questions? Yeah, there's one in there.
Fun talk. I had a question. So you coded kids for whether they were laughing or smiling or neutral. What about the fussy babies? Like, do they learn less? Or are they included as neutral? Or do you exclude them? I wasn't sure how you handled those children.
We include all you speak about the criterion of exclusion, no?
Sure. And are fussy and neutral like equated, or do you even look at fussy babies separately?
We take into account when the baby are fussy, just if it impedes the experiment, we exclude them, but it's not the case. We take into account the fact that they are fussy or not. But we have just to implement other behavioral analysis concerning the fussiness because generally the infants are not fussy during the demonstration, and it's because of this that we don't take into account this in our analysis for the first experiment, but we want to take this in account during the other experiment. Is it correct? Is this clear for you? Okay. I'm sorry, Maja.
That's okay.
Okay, our time is up. Okay. Thank you, Romain.